Question 32. Two particles A and B, each carrying a charge Q, are held fixed with a separation D between them. A particle C having mass M and charge Q is kept at the middle point of line AB. If it is displaced through a distance x perpendicular to AB, what would be the electric force experienced by it? Assuming x is less than D, show that this force is proportional to x. And under what conditions will the particle C execute simple harmonic motion if it is released after such a small displacement? Find the time period of the oscillation. So here, charge Q is located at this point, capital Q, this at this point, another capital Q charge, at this point, small q charge, and this is midpoint. So small q is displaced through distance x and it reaches to point this. Now, force between capital Q and small q will be in this direction, being a repulsive force that is denoted by F2, and force between this Q and the small q will be in this direction, that is F1, which is also repulsive, and it will be directed like this. Now, in magnitude, F1 and F2 will be equal. So let's write them as F, and we write the formula Q times small q divided by 4 pi epsilon naught, and this distance will be equal to x square plus d square by 4 using Pythagoras theorem. And here, if we analyze, we will get that f1 cos theta in this direction and f2 cos theta in this direction will get cancelled, and being in magnitude equal, so the f1 cos theta equal to f2 cos theta, and here in this direction only f1 sin theta plus f2 sin theta will be there. So we can say net force will be 2f sin theta in this direction. So net force we can say 2f, suppose we write it as f net, so that will be 2f sin theta. So this implies f net will be twice of f we have evaluated as capital Q small q divided by 4 pi epsilon naught x square plus d square by 4, and sine theta means perpendicular upon hypotenuse, so that will give x upon x square plus d square by 4 per power half. Now, we can write it further. F net will be equal to 2 capital Q small q times x divided by 4 pi epsilon naught x square plus d square by 4 whole power 3 by 2. Here condition is given that x is less than d, so we can ignore this term. So we will get 2 capital Q small q x divided by 4 pi epsilon naught times only d square by 4 power 3 by 2 will be left. So d square by 4 power 3 by 2. It means d cube divided by 4 root 4. So that will be d cube by 8. So we can write it as d cube, and 8 we can write in numerator. So we have got it as 16 capital Q small q x divided by 4 pi epsilon naught d cube. Clearly, f is proportional to x. Now, this is case of simple harmonic motion. So now, let's find out the expression for time period. So before that, we find acceleration. So F equal to ma. So this will give a equal to F upon m, and F is this much. So we put the value 16 capital Q small q x divided by 4 pi epsilon naught times m d cube. So this is acceleration. Now let's write formula for time period, and we know that time period t equal to 2 pi root L upon G. So here L will be replaced by X and G will be replaced by A. So value of A is this. So we put the values. T equal to 2 pi root of X divided by 16 QQX times 4 pi epsilon naught d cube times M. If we take this 2 pi inside the square root, so this will become 4 pi square, and here x will cancel out. So we will get 16 times pi cube epsilon naught M d cube divided by 16 q cube. 16 will cancel out, and it will simplify to become t equal to M epsilon naught pi cube times d cube divided by capital Q small q under root, which is our answer. Thank you for watching.